Hello everyone, welcome back to the series of tutorials on C++. I am Deepak Kunyal, and from the past few tutorials I am discussing about STL in C++. And now we are at the final part, which is iterators. As we have discussed earlier, iterators are used to point to the containers in STL. Because of iterators, it is possible for an algorithm to manipulate different type of data structures and containers. Algorithms in STL don't work on containers. Instead, they work on iterators. They manipulate the data pointed by iterators. Therefore, it does not matter what is the type of container. Because of this, an algorithm will work for any type of element and we don't have to define same algorithm for different type of containers. So what actually a iterator is? Suppose we have a container here and it has some element like 1, 2, 3, 4, 5 and 6. So iterator 1 that is pointing here and there is another iterator which is pointing to this. So this diagram is showing that iterator 1 and iterator 2 are pointing to the beginning and end of the vector. So this is beginning of the vector and this is end of the vector. So basically it's like a loop that we generally use for iterating container, or we can say a data structure. So it's something like that, right? So if you want to define an iterator, there is a definite syntax for that, and syntax for that is you have to write container type first because you want to define an iterator of this container type, and then you have to write a parameter list here, use scope resolution operator, write iterator in front of this. So these things are fixed, right? If you want to write vector iterator, you have to write vector here. Then if you want to have vector of integer type, or if you want to have iterator for this vector which is having integer values, then you have to use vector int scope resolution operator, then iterator, right? And when you are done with this, you have to use a iterator name, which is something like this, iterator, and then you can use semicolon, right? Similarly, in this case, when you are creating an iterator named something that I want to name, maybe I in this case. So here I am naming an iterator I, which is an iterator to a vector of integers. Similarly, here we are creating an iterator named k to a list of integers, right? Similarly, you can create an iterator named something else to a map of integers. So to a map of integers, you have to write something like this int, and int it has key and value as integers, and then use this scope resolution operator, write iterator here, and then you can write maybe mi, which is map iterator. So this map iterator is to the map of integers. So that's how you can create iterators in STL. Iterators can be used to traverse the container, and we can dereference the iterator to get the value of the element it is pointing to. So let's take an example of that. So let's create a vector first. Vector of integer having size of 10, and as we are just giving size here, so it's going to create a vector of size 10 and all the values will be 0, right? As we are not assigning any value here, so this vector will have all the values as 0 values. Then we have to create an iterator. So for creating an iterator, you have to use vector int, and then don't forget this scope resolution operator here, and I am naming it as I. Now I have to run a loop. So I should begin with b dot begin. It means I will be pointing to the first element. This is I, and I should not be equal to v dot end. So we will be moving I till it reaches end of this vector. So in the 10 elements, this is 0th element, this is 9th element, and v end is this, right? And after this we'll increment I by 1 each time, and here you can print value of these elements by dereferencing this iterator like this. If you know about pointers, you might be knowing about this dereferencing, right? So this is going to print all these values. At this moment it is just going to print 0, but we have some values here, right? There are some more operators that can be used with iterator, and they can perform various actions, like we have advance, distance, next, previous, begin, that we have already seen here, and end, and this we have seen here, right? So let's take one more vector and use it to understand the various operators that we have just discussed. So let's take a vector of integers, and this vector will have size 10. So again, this will have a vector of zeros. This is 0th index, this is 9th index. Again, if you want to create an iterator, you can do something like this, and that we have already done above, but I am doing it again. So this is defining an iterator to the vector of integers. You start I with v dot begin, and now I point to the beginning of the vector, means to this. Now let's focus and see how it goes. So we have advance. It will increment the iterator I by the value of distance. If the value of distance is negative, then iterator will be decremented. So let's pass some values here. So here is the advance function. You can consider that this first is the iterator and second is the distance. So it will increment the iterator by the value of this distance. If the value of distance is negative, then iterator will be decremented. So now I point to the fifth element from the beginning of the vector. So it means we have 0th element, first, second, third, this is fourth, and this is fifth element. So after this operation, this iterator will point to the fifth element. Let's perform one more operation, advance I, and then -1. And as it is at fifth position, after this operation, this will come a bit behind, and now this I is going to point to this fourth position, right? So that's how advanced function works. Other than this, there is another function called distance. So it's going to return the number of elements, or we can say the distance between the first and the last iterator. So it has two iterators, one is first and one is last. So we can do something like this, like I equal to v dot begin. Here I is an iterator like this, and similarly we have another iterator which is j, and we have I and j here. Now I am going to call this function distance and going to pass I and j here. So in this case, as we have 10 elements, so this distance is going to return the number of elements, or you can say the distance between first and the last iterator. So it will return 10 here. Clear? Because we have 10 elements and difference between this begin and end. Clear? Another function in the iterator that we have here is next. First argument here is iterator I, and another argument is int n. So this function is similar to advanced function, but here in this case, when we only use next, its value of n is by default 1. So it means it's going to advance by 1 by default and going to return a iterator. But in case of advance, it does not return anything, whereas next return an iterator, right? But if you pass some other value here, maybe 5, so this is going to advance iterator by 5 and return the iterator. Similarly, we have another function here which is previous, named prev, and it has similar signature iterator I and int n. So it will basically move behind from a particular point. By default value of n is 1, and then this is going to return an iterator, right? So this next and similar have similar signature, but this function can be performed by advance by changing the argument of distance. Clear? Now we have two more functions which we have already discussed. One is begin and another is end. So begin is going to return an iterator to the start of the given container, whereas this end will return an iterator to the end of the given container. Alright, so it was all about iterators in STL. In the next tutorial, we are going to implement some of the programs using STL. I hope you would have found this tutorial very interesting and helpful for your software development. And I hope now you'll be able to do your development rapidly and quickly. One thing that you have to keep in mind is that you need to practice all these algorithms or all these functionalities that we have discussed till now. I'm also sure that it's going to help you in the competitive programming where speed and accuracy matters a lot. So I think it's enough for this lecture till now. Now I will see you in the next video with some new concept. Till then, thank you so much.